So now I would like to do this final practice problem. It says, calculate the amount of heat in joules needed to warm 25.0 grams of ice at negative 30.0 degrees Celsius to 25.0 grams of steam at 140.0 degrees Celsius. Then you're given the heat of fusion of water. So that's the heat of fusion there. It's a reference to ice. It's 334 joules per gram. And then you have the heat of vaporization of liquid water is 2,255 joules per gram. And then down here, we have some values of specific heat for liquid water, for solid water, which is ice, and gaseous water, which is steam. So if I can reduce the slide. So this is kind of a problem that isn't difficult, but it's kind of painful, as you'll see in a minute. So what I'm going to do is I'm going to make a heating curve for water really quick. And so here we have point A going to point B, to C, to D, to E, to F. And so A here in our problem, we're going to start out at negative 30 degrees Celsius. And then B is the melting point. BC line here is 0 degrees Celsius. And then D, he is 100 degrees Celsius. And then F here is 140 degrees Celsius. And so to solve this problem, you really have to break this down into steps. And so the first step is to calculate the heat necessary to get solid ice from negative 30 degrees Celsius to 0 degrees Celsius. And the next step is to calculate the heat necessary to melt that amount of ice you have at 0 degrees Celsius. So the third step is to figure out how much heat is needed to warm up that mass of liquid water from 0 degrees to 100 degrees Celsius. The fourth step is to figure out how much energy is needed to boil or vaporize that mass of water. And then finally, the fifth step is to figure out the heat needed to heat up that mass of steam to 140 degrees Celsius. And so let's go ahead and try this. So step one, what you're going to have to do is figure out the heat here. We can call it step one if we want. And so this is going to be the mass of the ice, which is 25 grams, times the specific heat of the ice, times the temperature change of the ice. And so here, the mass of the ice is 25.0 grams. Specific heat in joules is going to be 2.03 joules over gram degrees Celsius. And then the temperature change, it's the final temperature minus the initial temperature. So the final temperature here is 0 degrees. The initial temperature is negative 30. So the temperature change is 0 minus negative 30. 0 minus negative 30 is 0 plus 30. So the temperature change is 30 degrees. Okay, and so if you work that out, what I got earlier was 1,522.5 joules. Okay, so the second step is figure out how much heat is needed to melt this mass of ice. So I'm just call this Q2. So this is going to be the mass of the ice, but then we're going to have to multiply it by the heat of fusion. A symbol for the heat of fusion we'll say is F. Okay, and so what we can do is we'll take the mass, which is 25.0 grams, and multiply by the heat of fusion, which is 334 joules per gram. And so if you do that, the number you get is 8,350 joules. Okay, so the next step is the third part here. So here we need figure out the heat needed to raise 25 grams of water from 0 degrees to 100 degrees Celsius. So again, you need M times specific heat of the liquid water times the temperature change. So again, it's 25 grams. Specific heat of water, you can look up. It's 4.184 joules per gram degrees Celsius. And then we multiply by the temperature change. And so it's final minus initial. So it's 100 minus 0. So it's going to be 100 degrees Celsius temperature change. And so if you do the math here, what I got was 10,460 joules. Okay, so we move on. We're almost done. So 4 here, this is the heat of vaporization. So it's going to be the mass of the liquid you're trying to vaporize times the heat of vaporization. I'll just write a V here for that. So here it's 25 grams times the heat of vaporization. The heat of vaporization is 2,255 joules per gram. And so you multiply those two numbers together and you get a rather large number. You get 56,375 joules. Okay, and the final change here we're looking at is the heat required to raise 25 grams of steam and temperature from 100 to 140 degrees Celsius. So that heat, we'll call it Q5, is the mass of the steam times the specific heat of the steam times the temperature change of the steam. So this is going to be 25.0 grams. Specific heat of the steam is 2.01 joule over gram degrees Celsius. And then the temperature change of the steam is 40 degrees Celsius. So if you do that math, what I got was 2,010 joules. So what we really wanted to know was the total amount of heat in joules to take water from negative 30 degrees at point A all the way up to 140 degrees at point F. So what you really have to do is to find the total. You have to add these energies together. 1 plus 2 plus 3 plus 4 plus 5. And so when I did this earlier, the number I got was 78,717.5 joules. And so I think I rounded it to correct significant figures, and that runs out to be 78,700 joules. Okay, well, thank you for listening to all that, and we'll see you next time.